Hello, and welcome to part 2 of a multi-part series where I go into detail on how to use the RF-DYNAM Pro design add-on module. If you missed part 1, I do recommend going back and watching that because in part 1 I discuss how to enter the input data that's needed to run a natural vibrations case on a structure. Right now I have all of my input data entered in the module, such as my mass cases along with my mass combinations. I also have everything set under my natural vibrations case tab. So all I need to do now is hit OK and calculate to run my calculation and see my results. You should see that we are going to go back into RFEM after the program meshes everything in the background and we run through our 4 different eigenvalues. So now that we are back in RFEM, we're still technically within the RF-DYNAM Pro add-on module, and you can see this in the drop-down box up here and also in the panel on the right-hand side. When it comes to viewing the results, the most relevant information can be found under Table 5, Dynamic Analysis, and then we can immediately jump to the Effective Modal Mass Factors tab. Here we actually can cycle through our 4 different eigenmodes, just so we can see what each of those look like on our structure. The most important thing we want to take a look at though is the last row down here, because in this row it will tell us the total mass participation of our entire structure. You can see that right now in the x direction we have about 1.8% mass participation, and in the y direction we have about 54.7% mass participation, and then in the z directions we have 0%. Having these low mass participation percentages is actually a problem, because if we take a look at section 12911 out of the ASC 7, it tells us that we have to have at least 90% total mass participation in each orthogonal or horizontal direction. So you can see right now in my x or y directions I'm not meeting that 90%. Now for this example I will only be focusing on the x and y excitations, and I will not be worrying about the z direction. So what I can do is go back into the module, go under my natural vibrations case, go under calculation parameters, and I can uncheck the z direction and hit OK. Now that'll clear my results, and just a quick note, if vertical seismic design is something you are concerned with, then I do recommend making sure you have adequate mass participation in the vertical direction. Now the question you may be thinking right now is, how do we get to this 90%? Well, the easiest way to do this would be to solve for more eigenvalues. I've only solved for 4 right now, but you will see if I solve for more, let's say 50 eigenvalues for a small structure like this, I can click OK and calculate. And then we'll jump back to RFM under Table 5 under Effective Modal Mass Factors. So 50 eigenvalues is relatively a lot, but now you can see that I have 93% mass participation in my x direction and 93.9% participation in my y direction. So now we might be interested in viewing what our dominant mode shapes are. If we take a look at mode shape number 1 here, you can see that this is our dominant mode shape in the y direction. Then we can also take a look at mode shape 13 here, and we can see that this is our dominant mode shape in the x direction. Now in contrast, if we take a look at mode shape number 5 here, you will see that we really have no mass participation, just some movement here with this x bracing. And this is really called a local mode. So you can see that we have 0.6% mass participation in the x direction for this, and only 0.4% mass participation in the y direction. So this is really not much interest to us, so we really don't need to pay much attention to this mode shape. Under the Natural Frequencies tab here, this is where we can view our angular frequency, our natural frequency, and also the natural period of our different mode shapes. So now that we have determined the natural behavior of our structure, Under the applied cases and combinations, we can now move into running a response spectrum analysis. So this is basically where this video will end, and in part 3 we will work on entering the input data needed to calculate an RSA, and we will go into detail about how that works. So look out for that video, and it will also be linked below in the description when it is available, and I thank you so much for watching.